Welcome to Mr. Chalk's Revision Tips. In this video, we will look at uses of alpha radiation, uses of beta radiation, and uses of gamma radiation. Today, humankind can use radiation for a number of different things, such as medicine, detecting the thickness of things, and even carbon dating. Americium-241 is an alpha emitter used in smoke detectors. Alpha decay can also provide a safe power source for radioisotope thermoelectric generators used for stable or space probes that were used for artificial heart pacemakers. Alpha decay is much easier shielded than other forms of radiation. Beta radiation can be used in tracers and monitoring the thickness of materials. And gamma rays, which are non-ionizing electromagnetic radiation obtained by the decay of an atomic nuclei, are more penetrating than other things and can be used for sterilizing materials or in things like radiotherapy. So if we looked at this question, so which one of the isotopes could be used in a tracer? The answer would be technetium-99 because it's got a relatively short half-life, so it's at safe level or doesn't stay in the body for very long. It's a gamma emitter, so can be detected outside of the body and is less ionizing than other types of radiation. Radioisotopes are used for tracers in industry and hospitals. They're used to find out what is happening inside objects without the need to break into the object. In industry, they can be used to find leaks or blockages in pipes, the route that water is travelling underground, or the track of dispersal of waste. So, if we're looking at this, so to detect or to locate a leak in an underground pipe, a very small amount of radioactive material that gives off gamma rays is put into the pipe. A detector is moved along the ground above the pipe, and the leak is located where there's an increase in the activity or where the radiation can be detected. One type of smoke detector uses an alpha source to detect smoke. The alpha particles pass between two charged metal plates, causing the air particles to be ionized. So the ions are attracted to the opposite charged plates, causing a current to flow. When smoke enters between the plates, some of the outer particles are absorbed, so less ionization takes place. So this means that there's a small amount of current flowing, and that causes the alarm to sound. So smoke alarms contain an alpha radiation source and a radiation detector. The smoke alarm stays off while alpha radiation reaches the detector. Why does the alarm switch on when the smoke particles enter the plastic casing? Some of the key things to talk about is that the smoke absorbs the radiation. So the smoke alarm would not work with a radiation source that emits beta or gamma radiation. Explain why? Key things to talk about are that beta and gamma radiation would penetrate the smoke, so no charge would be detected, or a change in charge wouldn't be detected, and the alarm wouldn't go off. In carbon dating or radiocarbon dating is a method for determining the age of an object containing organic material by using the properties of radiocarbon or a radioactive isotope of carbon. So carbon-14 is a radioactive isotope of carbon. There is a small amount of radioactive carbon-14 in all living organisms. So when they die, no new carbon-14 is taken in by the dead organism. So the carbon-14 it contained at the time of death decays over a long period of time. So by measuring the amount of carbon-14 left in the dead organic material, the approximate time since it died can be worked out. Some rocks contain traces of uranium. Uranium has a very long half-life and so by measuring how much uranium is left in the rock, its approximate age can be worked out. Gamma rays are a high-energy electromagnetic wave which is only stopped by thick lead. This means that it can easily pass through medical equipment such as syringes. As gamma rays pass through the packaging, they will inactivate viruses and kill bacteria. As long as the equipment remains in a sealed plastic pack, it will remain sterile. Radiation is used in industry in detectors that monitor and control the thickness of materials such as paper, plastic, or aluminium. The thicker the material, the more radiation is absorbed and the less radiation reaches the detector. So beta radiation can be used to measure the thickness of paper. So the thicker the paper, the less radiation passes through it. A sensor on the opposite side of the radiation source detects how much radiation passes through, so this controls the distance between the two rollers. The more radiation that passes through the thinner paper, the less radiation, the thickness or the distance between the rollers can be changed to go and alter the thickness of the paper. So in an experiment, a teacher puts a 2mm thick lead sheet in front of a radioactive source. She used a detector to count and counted to measure the radiation passing through the lead sheet in 1 minute. She then put different numbers of lead sheets, each 2mm thick, in front of the radioactive source and measured the radiation passing through it in 1 minute. So how does the amount of radiation absorbed by the lead change as the total thickness is increased? As it increases, more of the radiation would be absorbed, so therefore the count rate would decrease.
Thanks for watching.